Properties of exponents. So there are some rules when dealing with exponents that make working with them a lot easier and a lot faster. But there are some requirements for those rules, and the rules, you need to memorize them. Okay. The first requirement is that the terms, okay, the bases, okay, must be the same. They have to have the same base. I can't do anything with two terms that have different base. Even if the exponents are the same, if the terms are different, it doesn't work. Okay, the rules don't work. And we'll look at why in a little bit. Okay. So when you're multiplying terms with exponents, as long as the base is the same, you can simply add the exponents together. All right? So if I have 4 to the third times 4 to the fifth, that's going to equal 4 to the 3 plus 5, or 4 to the 8th. Okay? Pretty simple. Now the reason why this works is 4 to the third is really 4 times 4 times 4, right? And if we multiply that, I'll use the x as a multiplication here, by 4 to the fifth, which is 4 times 4 times 4 times 4 times 4, okay? We basically have 4 times 4 times 4 times 4 times 4, 8 times, okay? We're adding the 3 times that we're multiplying 4 by itself here, and the 5 times that we're multiplying 4 by itself here, and that gives us a total of 8, and it's all multiplication, okay? So that's why when we have the same base, if we're multiplying these numbers, we can just add the exponents, okay? Works the same for when we have negative exponents or when we're using variables. N to the negative 2 times n to the negative 8 is going to equal n to the negative 2 plus negative 8, all right, which is going to equal n to the, I've got a negative, and I'm adding another negative to it. That becomes a larger negative, negative 10. Okay. All right, so now moving on from multiplication, when you are dividing terms with exponents, all right, you still need the same base. Okay, I've got the same base here, I've got the same base here. You have to have the same base. All right, as long as you have the same base, though, all you have to do is subtract the exponents. Okay, so I have 3 to the 6th over 3 to the 2nd, and that's going to be equal to 3 to the 6th minus 2, or 3 to the 4th. Okay, if we want to look at why that is, we can do 3 times 3 times 3 times 3 times 3 times 3, or 3 to the 6th, over our 3 to the 2nd, 3 times 3. And then just like we do with a normal fraction, we can just factor out our 3's. Okay? Those factor out, and we're left with 3 times 3 times 3 times 3, or 3 to the 4th. Okay? Same thing with variables. Q to the 2nd divided by Q to the 5th. Keep in mind, if you are given the division symbol, that means this one is going to be on the bottom, or this exponent is going to be second. So it's going to be Q to the 2 minus 5, or Q to the negative 3rd. Okay? Now the last one, we actually don't have to have the bases the same because there's only one base. Right? We have one number, one base, that's raised to a power, and then we're raising that whole thing to another power. So we're raising this whole term to another power. which actually has the effect of just multiplying the two exponents together. So I would have my base, 3, and then I'd have 2, which is my first power, times 3, which is just going to equal 3 to the 6th. Okay? Same thing with variable or with a negative exponent. I have x to the negative 1/5 times 4, which is going to equal x to the negative 20th. Okay? The reason this works is because you are taking it to the power, which means you are multiplying this by itself this many times, right? So I'm basically taking 3 times 3, okay, that's 3 to the second, 3 times 3, and I'm doing that 3 times, which means I'm going to have another 3 times 3, and another 3 times 3. Sorry, my mouse is messing up. So that gives us 6, right? So it's 3 times 3 times 3 times 3 times 3 times 3, or 3 to the 6th. Okay, so concept 1, multiplying powers with the same base. We've gone over this, so this will be a short part of the video, but these are the kind of questions that you'll come across. Right? Your first step is to make sure the bases are the same, and your second step is to add the exponents and rewrite the term with the new exponent. Okay? You can also have more than 2 terms. You could have 3 to the 2nd times 3 to the 4th times 3 to the 5th. It's still going to come out with 3 to the 2 plus 4 plus 5, right? Or 3 to the 11th. Okay? With variables, m to the negative 3rd times m to the 8th equals m to the negative 3 plus 8, or basically 8 minus 3, so m to the 5th. Okay, last one. If I'm looking at this, my first job is to check the bases. This one is 4, this one is 5. Doesn't matter that they have the same exponent. I cannot evaluate that expression without doing 4 to the 5th, calculating out that big long number, and then 5 to the 5th, calculating that big long number, and then multiplying those two numbers together. Okay? There's no shortcuts if your bases are different.